Okay, so we're back, and we'll continue with our next speaker. That will be Marc-André Giroux. He comes all the way from Canada. He's from Shopify, and he really is into GraphQL, Rails, Relay, and also he likes to lift barbells over his head just for fun. So welcome, Marc-André Giroux.
Hey everyone. My name is Marc-André, and today we're going to talk a little bit about GraphQL. So who's heard about GraphQL here? So a lot of people. Who actually uses GraphQL? Okay, so a bit less. So I'm really happy to be here in Sofia for a couple of days. Yesterday I tried Rakia. It was so good. If you haven't tried it yet, do it. I suspect I might have a few more tonight after the talks. As you heard, I come from the cold Montreal, Canada. And I work at Shopify, where I basically help people sell things on the internet. So today we're going to talk about GraphQL. But before we start doing that, we're going to start telling a little story of how we currently fetch data from our client apps and how we structure our APIs generally. So let's start with a simple UI component and examine what data we need and how we're going to fetch it. And I've chosen the GitHub cart component here. And let's take a look at what we need here. We might have a card component here, and we might need a card resource for it. Inside, as you see, we have products. We might need a product resource too. And we might decide to have a product image nested in that too. So generally, how are we going to fetch this, right? We might start by using reusable endpoints or a typical REST architecture, right? And how would that go? So in a typical REST architecture, we'll have resources. And these resources might expose links, hyperlinks, to other resources. And by following these links, we're going to change states from, let's say, my cart resource to the product resource. So we might start by getting our cart. And that cart resource is going to return us maybe a few hrefs towards the products. So we're going to fetch those. And these product resources might point us towards the product images. And we're going to fetch us too. So that provides us some advantages, but there's also something a little annoying with this, especially on mobile and slow networks. And it's that way too many round trips. Like imagine on mobile having, I think we had 7 round trips there, is kind of annoying. So we try to find a solution to this, right? And sometimes we have something like this, query param, where we can tell, give me the cart, but also expand that resource and provide me with the products resource too. So that works, but what about deeper nesting? And what if I want to select only some fields of these products? So maybe you're going to do another type of query param and be like, oh, I want the products, but only the name, description, and price. That works too. I've seen many things working that way, many query params, and they're always different, and we kind of have to reinvent the wheel every time. And I've yet to see like a nice and pretty solution to this. So we might be tempted to use something else instead, such as custom endpoints. So imagine I want a cart with specific requirements, and instead of using REST and having full resources returned to me, I'm just going to build my own endpoint, and it's going to return everything I need. Pretty easy, right? We're done. Like, our client app is perfect. But as you might expect, things can get a little more complicated. We might have a cart version too, a completely different view of the cart in our app. And we're going to build a custom endpoint for that too. We might build another custom endpoint for the cases when we only want products and images, but nothing else. And things can get out of hand. It's a little annoying, right? So what ends up happening is that every time our client updates the views, creates a new view version or just the model changes itself, our server needs to either update endpoints or even worse, create new endpoints specific for these changes. And that's because we have this, if we come back to the REST or like reusable endpoints method, we have a specific relation with, between the client and the server, right? Our client's like, yo, give me the resource with ID ABC. And the server just responds, here's that resource with ID ABC. But what happens when you have a second version? The server needs to respond with that version too. So the server becomes responsible of the shape of the data that the client wants. So when views changes, the model changed too. So imagine version 3 is the same. Every time our view changes, our endpoint changes and the model changes. And we end up realizing that our views and models are pretty coupled. And this is where GraphQL comes in. What's GraphQL? We can finally talk about it. But actually, let's start by saying what GraphQL is not. So GraphQL is not a database. It's not some special kind of graph database either. It's not a library, right? You can't just install GraphQL and solve all your problems. And it's also not language specific. So what is it? So GraphQL is a simple query language that allows us to fetch data shapes instead of resources by specifying exactly what we require. But it's also a server spec, a spec that explains how a server lexes, parses, and executes that query. So this is a bit of my hello world example here. This query here is basically fetching my shop and its name. So I want the name of my shop. And what we have here, we have selection sets, right? The brackets here. And these tell GraphQL, I want to select these fields on that object. So it's fairly simple. So when we send that query to a GraphQL server, what's ends up happening is it's lexed, it's parsed, it's validated, and finally executed. And as you can see, this query language is a bit similar to JSON, but removing the values. And what we get in return is actually JSON. So it's pretty cool. Our query shape matches our response shape almost one-to-one. So here we have name on my shop. We understand pretty easily that name is a field on my shop. But what is my shop here? So it's not some special field or some GraphQL magic here. It's that GraphQL needs you to define entry points into the graph. So for example, this query would be equivalent in GraphQL if you defined both on the root of GraphQL. Here, shop with ID1 would be simply the programmatic way of getting my shop, but both are valid. So in that example, we would have defined on the root of our GraphQL schema, shop taking an ID argument and my shop. And we discover here a new feature of GraphQL, right? We have variables. And variables can be applied on fields. And you can kind of think of fields as a simple function that takes arguments and returns value. Let's take a more complicated example. Here, not only we have name on the shop, but we have its location and products. And location and products are not exactly like name, right? Name is a scalar field, which returns like simply a string, for example. But location and products here are complex fields. We call them object types. And we can query other fields on these object types. So you can probably guess what the response is going to look like, right? It's a little bit like our previous example. It matches the shape of our query, but it filled that with the actual values. And all that's possible. Like, how could a GraphQL server know that my query here was valid and that it could respond to me? And that's possible because of the type system. At the core of GraphQL is a really powerful static type system that allows you to define exactly what's possible. So let's walk through that query and see how the type system applies. As I talked about earlier, my shop is on the root of our schema, and we have that type defined. So on the query root, we could fetch my shop, or we could fetch shop with an ID. That type would then return the name, location, and products of the shop. And we know that because there's a type attached to it. And you can imagine how the query goes. It's the same. Location returned us a location type, or address type actually, with a city and address. And products, they return us a product type with name and price. So if I take this query, does it look valid to you? Obviously, we know it's not valid because it doesn't make sense to have a YOLO field on my shop. But the type system knows that too, and on validation can refuse to respond to us with a response. And not only does the server know that, but the client can know that too through introspection. At the root of a GraphQL schema, we can find a special schema field that enables us to query meta fields on a GraphQL schema, sorry. We can fetch the fields, the description of the fields, the name of objects, and that allows a client to be pretty much as intelligent as the server schema. And it allows us to do really fun stuff, like auto-documentation, for example. We have everything the schema is capable of, and we have the name and description of those fields. We can do code generation. Imagine we have some front-end code. We can guess the GraphQL types behind them because we have the schema. We can do static validation on the client. It's useless to send a query with YOLO on my shop if we know client-side that's not possible. And we can also do some really nice IDE integration, like auto-completion of GraphQL queries, validation in the IDE. And this is one example of what we can do. And this is called Graphical, and it's a GraphQL Schema Explorer built in JavaScript. And this is really awesome, right? We can navigate through our entire API really easily, and we know everything that's possible on the right-hand side here. And it's really super fun to test, and that's when I found that tool, it's really when I really got amazed by GraphQL. It kind of looked like this. So far, we've been sending like a huge query with everything we need to the GraphQL server. But sometimes we like, as developers, to decompose things into smaller things and maybe recompose them later. And like we do that with modern UI frameworks like React, right? We divide stuff in components. And for example, if we had a product component here, in reality, the only data it cares about is the product data, right? So the ID, name, and price. So it would be nice if we had that kind of abstraction in GraphQL too. And it turns out it exists, and it's called Fragments. So we can extract certain parts of our queries into fragments, and all we need is name it and the type on which it applies, and we can reuse that fragment inside our original query. And that allows us to do really fun stuff, especially with React and modern UI frameworks where we have components. We can do something like this, where each component has its own fragment, and at runtime, when the query is actually sent, it's aggregated into a bigger query. And there's not only reads, right? We can write with GraphQL too, and they're called mutations. And a mutation is very close to a normal field, except they're not nested. We have a mutation root and a query root. And on the mutation root, it's only top-level actions, such as create product here, and they have a side effect. But we have the same capabilities of like getting only what we want back from the result. And the cool thing about GraphQL is that you don't really need to change much about your existing business logic. It's all backed by your code. And in Ruby, we can use GraphQL Ruby, which is an awesome gem. And it basically allows us to create that schema and execute the queries we receive. So let's go through a bit of code examples so you take a look at how it looks like. So let's start with maybe defining our product type. And that's quite simple. We give it a name and a description. That's the basic stuff. And then maybe we'll have fields on that product. So for example, the field name here is pretty much just a one-to-one mapping with the database. We're just getting object.name. By the way, every field has a resolve function here, which takes 3 arguments. Object, as a first argument, is the parent object, so it would be the product here. Args, which are arguments you've passed to the field. And context, which is a kind of a top-level context you pass with your query that could contain any like session-related stuff, authorization, authentication, and anything else really. But other fields are not one-to-one mappings to the database, right? We can compute some new fields, like price might be a calculation like this. So now that we have our product type, we can maybe have our shop type, where we define our products field on it. And it's quite simple to build our schema, right? We have our query type here, which will be the root. And we build our schema, just like this. So the tricky thing here is that our queries can be pretty large, right? So we can't really use get, because query params are limited in length, right? So we'll have to post to our endpoint. And let's take a look at our controller. We'll need 3 things, right? The query string, which will contain our query. Variables that are any variables we're going to pass to our fields. And the context object I was talking about. And with these 3 things, what we're going to do is simply tell our schema to give us a response. It's very simple. And funnily enough, using GraphQL helps you. Basically, our controller here only takes care of HTTP stuff, right? You might use cookies, session, and then the rest is all given to your schema. So that's pretty fun. But it's not a silver bullet, right? It definitely has maybe some issues and more complex stuff that we need to work around. And the first one is the infamous n+1 queries. And let me give you this example to understand better. Let's say we have on our shop type the products field, which returns an array of products on your shop. And let's say we have image field on that product type. And the image type is, the image field is very simple. It just gets the image of the product. If we send a query asking for all the products on a shop with these types, something like this would happen, right? Each image is loaded individually, and that's because the resolve function of our fields are not ran in batch, right? They're ran in different contexts, and they can even be ran concurrently. So at Shopify, we actually built a solution for this called GraphQL Batch. And it's quite simple. You define loaders, which will take care of loading that image, for example. And here what we're saying is that instead of fetching the image of the product right now, just take the ID, remember it, and when all the resolves have ran, batch it and load all these images at one time. And that helps us avoid that n+1 query really easily. Another problem is HTTP caching, right? You've seen our queries can be pretty big, and we end up having to use post to get them. And the solution to this problem is actually quite complex and might afraid of a few people when you see this, but it's a client-side cache. That's the solution most people tend to go towards because of the HTTP caching that we lose. And that's usually a normalized cache that we use. Because take a look at these queries. Let's say I fetch all the products on the shop, but I have another query after where I fetch one particular product with ID 1. If I was to cache them on a client side in the way they're structured right now, maybe in the first query here, I have the product with ID 1, and in the second one, I also have the product with ID 1, but they'll be located in 2 different places in my cache, right? Because one would be under the products key, and the other one might be under the product 1 key, right? So what ends up happening in our client-side caches is we're going to use link. We're just going to normalize our data, something like this, right? Products, instead of having the actual product here, we're going to have a link towards the actual product. And now both queries are in sync because they point to the same product. And Apollo and Relay are 2 examples of client-side caches, and they're really awesome. And the reason why they're so awesome is that having a client-side cache not only resolves that problem where we lost HTTP caching, But we can do fun stuff on the client now because we have all that data, right? So what Apollon really can do, for example, is diffing your query before sending it to the server. For example, if I have a query that asks for the name of my shop, and I have another query that asks for name and description, my client-side cache is intelligent enough to say, I already have name in my cache, so I'm going to diff the AST of that GraphQL query and simply keep description because we don't need name, right? And another thing to keep in mind is security. And if you read on Hacker News about GraphQL, there's always this one person that says, GraphQL is not secure, I'm never going to use it. You can query anything in your database, it's not secure. But by now, you all know that we've defined our schema ourselves and defined only the fields that we want to expose. So that's not really a security issue. But what people can do, though, is create malicious queries. And malicious queries, I mean very complex queries that might overload your server. Because nothing's stopping you from having circular data in your schema, right? Product might point to an image, and image might point to a product, for example, and somebody could craft an insane query that would overload your server. And there's a few things we can do to stop that. We can use simple timeouts, just dropping a query if it takes more than 1 second, for example. But we can do more clever stuff, like having a max query depth. So the server, while executing a GraphQL query, might keep in mind at which depth he is. And let's say if you said max depth 10, at 10, we drop that query. And we can also do other things like query complexity, which basically you give a score to each field. And while executing, by adding these scores, if it's bigger than that max score, we drop that query too. So everything I've showed so far is part of the GraphQL spec, and we can use right now in most GraphQL servers. But there's also some stuff coming in development that are really interesting too. And one of them is subscriptions. So we've seen that we have the ability of querying exactly what we want, and we have that client-side cache to keep it. But it's pretty hard to invalidate, right? And what if you care a lot about the inventory of a certain product, for example? It would be nice to have real-time updates, and that's exactly what subscriptions do. They look like normal fields do, but instead you indicate to the GraphQL server, I really care about products and the inventory. So every time that changes, send me the response again. And that's a pretty cool feature that I'm excited to see landed soon, I think. Another really cool feature that's coming is deferred queries. So imagine you have that query. We fetch the name, description, and products of a shop. But in reality, maybe we want to show on the client side, we want to show the name and description as fast as possible, especially on slow clients. And maybe the products of that shop, we can afford to have a little later. And we can do that with what we call in GraphQL a directive at defer here, which basically indicates to the server, listen, I really want name and description now. If products takes a long time to compute, for example, just send it to me later. And what is happening is that we're going to split that AST in two. We're going to get the first one and then the second one later. So let's go back to our original client-server relation here. We had the typical conversation we have, give me this resource with ID, and the server would answer with a resource. But even worse, maybe the server answered with a bunch of hrefs, and the client wants all of those too, and the server is kind of sad, right? But with GraphQL, we kind of inverse that relationship. We change it a lot, because clients are requesting data shapes instead of resources this time. And the server knows what's possible, so he tells the client, here's everything you can do. So he expresses the capabilities, and the client just knows what it needs, right? And it needs a data shape, not a particular resource. That's really cool. And that's real separation of concerns, right? Because when the client requires more fields or needs different fields, the server really doesn't care. And that brings us two really awesome things that GraphQL does well, is efficiency, right? Because we've cut down the round trips. We do one query. And predictability, because we only query what we need. We don't overfetch. We don't underfetch. And notice we've never seen any like select star in these queries. We have to go down to leaf nodes and saying exactly what we need. So I'm really excited to where GraphQL is going. Just last week, GitHub announced that they were releasing a public GraphQL API. We've been playing with it at Shopify too, and we have a lot of fun. There's a bunch of companies adopting it. So I'm really excited to see where it's going, and I hope you guys give it a try, at least, and have some fun with it too. Thank you.
Thank you, Mark. I hope next year when we ask how many people use GraphQL, there will be like a wall of hands. It looks so awesome. If you have any questions for Mark, just grab him in the hallway and chat with him. And we're going to have a 10-minute break. So make sure you check the coffee and the sweets in the sponsors hall. And we'll be back in 10 minutes. Thank you.